This is the third video from 6.5 notes. In the last two videos we talked about simplifying radicals and doing some operations, multiplication, subtraction, addition with radicals. In this section we're going to look at rationalizing the denominator and then also dividing, which requires multiplying by the conjugate. So when rationalizing the denominator, this is something that's been on your weeklies recently. We've also done this a couple times. We know that you cannot have a square root in the denominator. If you do, you have to keep simplifying it. So that's what this is telling you in this chart. So check this out. That's what the chart's saying. And then right here, this is saying it's not a good example because there's a radical 3 in the denominator. This is also not a good example because if you have the square root of a fraction, you could split it to the square root of 1 over the square root of 3. So this means the same thing, that there's a radical in the bottom. These two are good. You can have radicals in the top as long as the denominator does not have a radical. Alright, so let's take a look at number 14 and let's see if we can rationalize the denominator here. So to rationalize the denominator, what we do is we multiply by the radical in the denominator to top and bottom of our fraction. And the reason why we do that is because when we multiply radical 6 by radical 6, it turns it into radical 36, which is equal to 6. And you can see how it gets rid of the radical for us. Alright, so remember, multiplying by something to the top and bottom is really just multiplying by 1. So we're not changing the value of this fraction. We're just looking at it in a different lens or changing its form, but still the same value. Okay, so multiplying by radical 6 for number 14 to top and bottom. Let's see what that's going to do for us. So we're going to have 3. Radical 5 times radical 6 is radical 30. And then radical 6 times radical 6 is radical 36, but that's just 6, right? So we got 3 radical 30 over 6. And then one thing we need to do is see if we can reduce the things that are outside of the radical. Sometimes they reduce, and then sometimes the square root in the top might simplify, so you need to check that. 30 doesn't simplify because it's just 5 times 2 times 3, and that's not going to simplify at all. So not worried about the radical itself, but I am looking at this 3 and 6. That can reduce by a factor of 3, and that's going to give me 1 radical 30 over 2. Alright, let's try number 15. Okay, so we see the issue here. The issue is we have a radical 5 in the denominator. I need to get rid of that. So I'm going to multiply by radical 5 to top and bottom. So notice I did not multiply by the 4. That's not going to really do anything for me. It would still get rid of the radical 5 if I multiplied by 4 radical 5, but it'll also inflate the numbers a lot, and it's just unnecessary. So I'm going to multiply by radical 5 to top and bottom, and that should do what I need it to do. So let's see what happens. So this is going to become 7 radical 30 in the numerator. And then in the denominator, I've got 4 still there. And then radical 5 times radical 5 is just 5. So I've got 4 times 5. Which is 20. So 7 radical 30 over 20. Radical 30 doesn't go any further, and 7 and 20 don't go any further. They don't have common factors. So that's as far as we could go for number 15. Alright, let's move on to multiplying by the conjugate in order to get rid of the radicals in the bottom. Okay, so the conjugate, what is it again? Well, it's just when you're looking at the binomial in the bottom, if you flip the symbol in between, that's the conjugate. Now, why do we call it that? Well, when you multiply by the conjugate, what happens is middle terms eliminate, because it's a difference of squares type problem. So what's going to happen is you're going to be left with the first term and the last term, the squares of those, and the middle terms eliminate. So let's go ahead and use this multiplying by the conjugate technique to get rid of the radical 3 in the bottom. Okay, so I'm going to times this fraction by its conjugate, which is 5 minus 2 radical 3. Make sure we're doing it to the top and bottom. Okay. When I multiply 10 times the binomial, I'm going to get 10 times 5 is 50. 10 times negative 2 is negative 20 radical 3. So there's the top. And then the bottom, I'm going to go ahead and just write everything out for the first time. But then I want you to catch on and realize what happens, and it should save you some time in the next one. So 5 times 5 is 25. 5 times negative 2 radical 3 is negative 10 radical 3. And then 2 radical 3 times 5 is 10 radical 3. And then 2 radical 3 times negative 2 radical 3 is negative 4. And then radical 3 times radical 3 is 3, right? So I've got negative 4 times 3. I'm going to just put negative 12. Alright, now hopefully you see these middle two terms eliminate each other, and that's going to happen every time if you multiply by the conjugate, okay? So those are gone, and what I'm left with is, still have my 50 minus 20 radical 3 in the top, and then in the bottom, I've got 25 minus 12, which is 13. Okay? Now when I look at those coefficients, or those integers that are not underneath the radical, I got 50, negative 20, and 13. Those do not reduce at all. If they were all, like say if the denominator was a 10 instead of a 13, I would reduce all those by 10. But in this problem, nothing reduces, and I'm going to have to leave it like that. Alright, let's try one more of those. So example 17, last example from this section. What am I going to multiply by? Okay, so the conjugate would be 2 plus 5 radical 10. So multiply by that to top and bottom. So the top I am going to have to distribute since it's two binomials. 8 times 2 is 16. 8 times 5 is 40 radical 10. Negative 5 times 2, or negative radical 5 times 2 is just negative 2 radical 5. And then negative radical 5 times radical 10, still have the 5 out here, is radical 50. Alright, now I already know what's going to happen in the bottom. So instead of writing everything out, I know the two middle terms are going to cancel, right? So I'm just going to do the first term and the last term. So 2 times 2 will be 4. And then the last term is going to be negative 5 times 5 is 25. And then radical 10 times radical 10 is 10. So that's going to be negative 250. So notice I didn't even worry about the two middle terms there because I know what's going to happen. Alright, let's see if I can do any simplifying. So in the top, I do see a radical 50. That could be written as 25 times 2. Square root of 25 is 5. So I can pull out a 5 from this. So this is going to be, I'll just put it up here in green so that you're not getting confused. So I'm looking at just this guy here. That is 5 times 25 and the radical times 2. And this can be pulled out to another 5, right? So that's going to be 25 radical 2. So that's what I'm going to put for that term. So I've got 16 plus 40 radical 10 minus 2 radical 5. And then this we just said was 25 radical 2. Alright, and then in the bottom, 4 minus 250 is negative 246. And then looking at the top, I don't see any radicals that can be combined. We've got 3 different radicals, and they don't have that same number, so I cannot combine those. I'm going to have to leave them separate. Now, one thing that I do notice is I have a negative in the denominator. If you left it this way, I would be fine with it. But a lot of times, if there's a negative in the bottom, we like to distribute it up to the top. So I will do that, and I'll just switch this to a negative 16 minus 40 radical 10 plus 2 radical 5 minus 25 radical 2 all over 246. So I'm going to leave it like this, and there's nothing else that we can do with that problem. Like I said though, if you left it this way, I'm okay with that too. Alright, thanks for watching all of these videos from section 6.5. I hope you found these videos helpful, and go ahead and make sure that you're working on the assignment that goes with the notes here. Thanks for watching.